This is part 2 of the Florida Geometry and of course practice exam. I got it from the fsaassessments.org website. This is a Florida-based geometry and of course exam, but it could be used to practice for any geometry and of course exam. Part 1 is also shared earlier. So let's get started. Okay, so we have here for number 13, part points. I gotta put my glasses back on. Points A, B, and C are collinear, meaning they are on the same line, and the proportion of AB to AC is 2 to 5. Point A is located at -3.6. Point B is located at -3.4. The first thing I notice is they both have x values of -3. So if I were to graph this on the graph, here's x is -3, this is the x, and this is the y, and that's going to give me basically a vertical line, right? So point A is located at y is 6. So that's right here, point A. And point C is located at -3, -4. So here's C. So the distance from A to C is 6 to the axis, and the axis to 4 is 10, right? So if I were to look at my proportion, AB to AC, well, I know that from A to C is 10. So I'm going to put that and fill this in to figure out what AB is. So from 5 to 10, that's times 2. 2 times 2 is 4. So from A to B is going to be 4 points. So I'm going to count down 4. 1, 2, 3, 4. And this is going to be point B. So B is at 2. And well, the y value of B is at 2. The x value is at -3. So they put N and Q for B. So N is X and Q is Y. Okay, let's not get these mixed up, because if you switch them on accident and put the wrong value in, you would get it wrong. So I know that because N comes first, it's the X value, and the X value is -3. And the Q is second in the coordinate point. So that's the Y value, which is 2. So our point for B is -3, 2. Okay, we have quadrilateral math, and it's shown, and it's dilated. Dilated means it gets bigger or smaller, like your eye in an eye exam, or Alice and Alice in Wonderland when she eats those things in that tunnel. So it's dilated by a scale factor of 2.5, centered at 1, 1. Okay. So what that centered is, it doesn't mean the very center of the drawing. It means that's where it's going out from. Okay. So 1, 1 is at point A, and 2.5 means it's going to be 2.5 times bigger. So it's getting chilly in my room. I am in South Florida, and it's supposed to get in the 40s tonight, and I'm not a big fan of that. I should have turned my space heater on before I started this lesson. So Okay. So it's going to be 2.5 times bigger that way and 2.5 times bigger this way. And I'm not drawing this to scale by any means, but let's just say that the new drawing would, okay, that's completely off, but you know, it's 2.5 times bigger. Imagine it's to scale, okay? So that would be like the new one. Select all the statements that are true about the dilation. Well, the measure of, okay, says all, so that tells me that there's going to be more than one answer, right? So for A, the measure of MA is the same as the measure of the new MA. And the new one is the one, the dilated with the little apostrophes. So this is the new MA. Those two, like this, is not the same as the original one. So that is not correct. So for B, the new AT, which is this line, will overlap the old AT. That is true because it is overlapping the old one. So B is one of our choices. Okay, so the new MA, the dilated one, will overlap the old MA, and that is true. It does overlap it. Okay, let's look at D. The slope of HT is equal to the slope of the new HT. Well, not in my picture because I did not draw it correctly. But the slope should be the same. Like this slope and this slope should be the same. The slope didn't change any, it just got bigger. Okay, then the last one says the area of the new MAT is equal to 2.5 times the area. Well, just because it was dilated 2.5 times does not mean the area is the same. Clearly, if you were to draw to scale, the area is much, much bigger than 2.5 times. And if you really wanted to like do the math, you could figure out the area of the first one and then the area of the second one. If I wanted to, I could find the area of the first one and multiply that by 2.5, and it would be nowhere near as big as the area of the second one. So E is not correct. Okay. Let's go on to the next one. One diagonal of square EFGH is shown on the grid. So this is the diagonal of a square. And let's see, complete the sentence to describe the square. So I'm going to draw the square. So let's see, the midpoint of my line, I think, no, that's not it. I think that's it. Okay, so I think that's my midpoint, and I'm just kind of doing like a reverse slope to get other points. So here's my square. Yes? Eyeballing it. So E, F, G, H. So this could be F and this could be H. So the location of point F could be, is it -1? I'm looking at the X values. It's definitely not C because -8 is like way down here. So is it -3 or -1? Well, it's not -3 because that would be like directly over E. So -1, 6. Oh, I did a good job of eyeballing it. Okay, So that is our point F. Now I have to scroll down to see the other questions. Diagonals of a square are congruent, meaning they're the same length, and they do what? Do they have the same slope? No, their slopes are opposite. What else? Do they bisect each other? Diagonals of a square? Or are they perpendicular? They are perpendicular. They form 90-degree angles. Okay? All right. Okay, so here we have polygon ABCDE, and they want to know what the perimeter is. This one isn't so bad. So first, let's look at AB. Side AB, I'm going to do in orange. It goes from -3 to 1. So from -3 to 1 is 4 spaces, right? And ED is the same. It goes from -4 to 0. That is also 4 spaces. So far I have 4 and 4. Now I'm going to look at side EA. This is the side right over here. And what I'm going to do is make a triangle right here. Okay. So I can use the Pythagorean theorem to figure out what the hypotenuse is, or side EA is. So the A side is 1. Remember, the Pythagorean theorem is a squared plus b squared equals c squared. So 1 squared plus, and then this side, the up and down side, is from -3 to 2. So that's 5. So 5 squared equals c squared. So 1 squared is 1, 5 squared is 25 equals c squared. So 1 plus 25 is 26 equals c squared. Square root of 26 equals c. So square root of 26. I'm probably going to need to figure that out on a calculator. Now let's look at side BC. Well, let me find out what square root of 26 is really fast. Did you know that on your calculator, you can turn it sideways and get like a scientific calculator? It's pretty cool. Okay, so 26 square root is 5.099. All right. So for side BC, I'll make that this green color. And well, let me do the triangle on the outside. So from here to here is 2, and from there to there, up and down, is 3. So that's going to be 2 squared plus 3 squared equals the hypotenuse squared. 2 squared is 4, 3 squared is 9, and 4 plus 9 is 13. So square root of 13 equals c. And if I look at the other side, it's the same thing. So there's a side of 2 and there's a side of 3. So it's going to be 2 times the square root of 13 because there's 2 sides that are the square root of 13. And 13 square root is 3.6 times 2 is 7.211. So I'm going to add these up. That's 5.099 plus 8. And that gives me 20.310. And I'm rounding it to the nearest hundredth. So that's to this place. So it would be 20.31. Okay. So don't round until you're like done with the problem and then round. Otherwise you might get it wrong. Okay, so Reuben carries out a construction using triangle ABC. A sequence of diagrams shows part of his construction. So he has a compass, that's the little pointy thing, and his triangle. And he puts the point of the compass on angle B, and he draws a line, right? Okay. And then he puts the point of the compass on the line right there, and he draws another line right here. So I'm guessing he didn't change the angle of the compass any. So what would happen if I were to draw a line connecting like the point B and the new thing he just do? What do you notice? What I notice is this side and this side are the same. So it looks like you cut the angle in half, doesn't it? Let's look at the answers. So he didn't make a perpendicular one because perpendicular is like 90 degrees, right? Did he make a bisector? Did he cut the angle in half? Did he bisect it? Possibly. Did he make an angle congruent to angle B? Well, no, because they're both smaller. Did he construct the bisector of angle B? Well, did he bisect the angle or did he bisect the side? I'm pretty sure he bisected the angle. So let's go with this one. Number 18, we have a cone of phosphate, not as tasty as ice cream. Don't try it at home. And it falls off the conveyor belt into a cone. And a shorter conveyor belt also has phosphate falling off into the shape of a cone. But the height of the second one is 3.6 feet shorter, but they have the same volume. Hold on just a second. Okay, so we got our two cones, same volume. One is taller than the other one. So if I were to draw the second one, I don't know where I want to draw. I'll draw it next to it. It's not to scale, obviously, but it's going to be wider and shorter. Well, pretend that it's okay. So my cone is a little bit crooked. But the height on this one is 3.6 feet shorter. So this is part of the test that I can use a calculator on, and I'm going to take advantage of that. 15.3 minus 3.6. When you're taking the test, usually they'll have like an on-screen calculator that you can use, like a TI-83 or TI-84. So the height of this one is 11.7. I'm going to double check that because I make mistakes a lot. 3.6. Yes, so the height is 11.7. So we need to figure out what the diameter of the second pile is. That we do not know. So we're trying to figure it out. We do know the volume. Well, not yet, but we can figure the volume out. So what is volume of a cone? Volume of a cone, you can refer to the handy formula sheet or the reference sheet at the beginning of the test. I'm not going to scroll off this page to get to that, but volume of cone is 1/3 the area of the base times the height. Big B for area of the base times the height. So the base of a cone is a circle. So 1/3 times pi r squared, because the area of a circle is pi r squared, times the height. So that's the formula. And now we can plug in for what we know. We know that the height is 15.3. And we know that pi is 3.14. And what is the radius? So half of 48.6 is the radius. So half of 48 is 24.3. Okay. So 24.3 squared. I kind of squished that in there a little bit too much. Okay, so I'm going to start with the 24.3 and square it with my calculator. 24.3 squared is 590. Oh, you know what? I put a 2 there instead of a 3. 590.49. I'm going to rewrite this down here so it's not squished. Okay, so 590.49 times 3.14 times 15.3 divided by 3 is 9456.10686. Okay, so that's our volume. And now I can say the volume equals 1/3 the area of the base, or pi r squared, 3.14, times radius squared times the height. And the height of the smaller one is 11.7. So now we're like reverse engineering it. So I have this big 9,000 number. I'm going to divide it by 11.7. And that gives me 808. And then I'm going to divide it by 3.14. And that gives me 257 something. And then I'm going to multiply it by 3. Now I have 772.179 equals r squared. And if I take the square root of this, I get r equals 27.788. So to the nearest tenth is to this place. So I'm going to round that up to 27.8. And that's the radius, okay? Well, hold on. I would have gotten the answer wrong because I was just about to write 27.8 into the thing. That's only half of it. So 27.788 times 2 to get the diameter, because remember we're looking for the diameter, is 55.576. So I'm going to round this 5 up to a 6. So it is 55.6. And that is the diameter. So be careful with questions like this. I almost put in the answer to the radius and I would have gotten that wrong after all those steps. So make sure you know exactly what they are asking for. Okay, Gabriel wrote a partial narrative proof to prove that FD, let's see, FD, oops, right here, FD is congruent to BD. So these two sides are like the same length. And he starts off saying that AD bisects EAC. So these two angles are the same. And that angle FDA, let me make this different color. FDA is the same as BDA. So these angles are the same, these two pink ones. Prove that FD is the same as BD. So let's look at this and determine what we have. We have angle, right? Angles that are the same, and we have this angle that is the same. What else is the same that we know for sure? I'll give you a hint. AD, because in either triangle, AD is a side of it, and that's a side, right? AD is a side, so angle, side, angle. All right. Now, we have 3 lines down here to fill in. We know that AD, the side, bisects EAC, those orange angles I put up top. And we know that the pink angles, FDA and BDA, are the same. Since AD bisects EAC and DAE, those orange angles I put up top, from the definition of the angle bisector, and that AD, that's the green side by the reflexive property. So triangle what is congruent to triangle what? Well, let's look at our triangles. And our triangle is going to have to include those orange sides in it because that is what we're trying to prove, right? That these sides, that FD and that BD are congruent. So the triangles are going to have to include FD and BD in it. So I think that for the first one, it's going to be DAF or DAB, either one. So it could be this one or it could be this one, right? So let's say DAF is this orange triangle and DAB is this green triangle. Okay. 2, so DAF would be the same thing as DAB. So I'm just color coordinating like these. These could be answered either way. You just have to make sure like these two go together and that these two go together. Either way would be correct. And then we know that because of angle, side, angle. So that's ASA. So that would be the answer. Therefore, the two sides are congruent. So this problem is a little bit confusing because you could have answered DAF for the first one and DAB for the second, or DAB for the first one and DAF for the second. Just make sure you get both of the triangles in there. And then you're looking at your angle, side, angle that was introduced to you in the problem. Alrighty. The population of Florida in 2010 was 18 million something something, and the land area was 53,000 something square miles. The population increased 5.8% by 2014. So if it increased by 5.8%, I'm going to multiply it by, where'd my pen go? I'm going to use my calculator and multiply it by 1.058 because the 0.058 is 5.8%, and the 1 is for like the original 100% of the population. So this is a good tip. Like if you're leaving a tip for somebody at a restaurant, you want to leave like a 10% or 20% tip, you could say times 1.2, and that'll give you like the total amount you should pay. Anyways, back to the problem. The population increased, so I'm going to multiply the 18 million number by the 1.058. So 18,801,310 times 1.058. And I get 19,891,786. So all that did was save me a step. Instead of multiplying 18 million by 0.058 and then adding it to the 18 million, I kind of did it all in one step. Now, this is saying, what is the population density in people per square mile? So people per square mile, people, I spelled people wrong. This is why I teach math. Okay, people per square mile. So people over mile. So we have people and mile is on the bottom. So we're going to divide by the 53,625 using the calculator. Thank goodness. 53625. And that is 370.94. And it says to the nearest whole number. So I have to round up to the nearest whole number, which would be 371. 371. Okay. For the second part, it says to the nearest whole number, right? We're going to round up to the nearest whole number again. How much did the population density and people per square mile increase? Well, what was the population density to begin with? So we're going to divide, I'm not going to write it all out, but the 18 million number divided by the 53,000 number, okay? So 18,801,310 divided by 53,625. And that gives me 350.6. So I'm going to round that up to 351. So the original population density was 351 people per square mile. And the new one is 371. So how much did it change? So 371 minus 351 is 20 people per square mile. So 20 is the answer to part 2. Okay, here we have the Leaning Tower of, I want to say pizza, but I know it's not pizza. It doesn't look like pizza. It shows how long it is. And in the 90s, engineers restored it so that the angle Y up there at the top changed from 5.5 to 3.99. So we basically have the hypotenuse of a triangle. We have the angle of Y, and we're going to have to do it twice, right? And we're looking for like how much the height changed. We can't use the Pythagorean theorem for this. We're going to have to use sine, cosine, tangent. And if you scroll back to the beginning of, well, not this video, but the other video, there was a reference sheet that had our sine, cosine, tangent functions in it. And what we need to do is look to see what things we have. So I know that we have the hypotenuse, right? I'm trying to draw. Okay, the hypotenuse of the triangle. We have this angle y up here, and we have it's either opposite or adjacent. We're looking for the height, so that is the adjacent. I should write it like a big capital A. That is the adjacent side. So we have the hypotenuse and we have the adjacent side. Referring to our trig functions, that would be cosine. So cosine of the angle equals the adjacent side over the hypotenuse. So what we're going to have to do is this twice. One time with the angle 5.5 and one time with the angle 3.99. So let's see if I do 5.5, so cosine of 5.5 equals the adjacent side over the hypotenuse, which is 56.84. So I'm going to use my calculator, and I'm going to put 5. On my calculator, I had to put 5.5 in first and then hit cosine, and I get 0.995, a whole bunch of numbers. I'm going to multiply that by 56.84 to get the A by itself, and I end up with 56, and at the very end, we're looking for the nearest hundredth. So I'm going to leave some decimals after that. 5783. Okay. Now I'm going to do the same thing with the other angle. So cosine 3.99 equals A over 56.84. So 3.99 into my calculator, hit cosine, I get 0.997576, bunch of numbers. I'm going to multiply that by 56.84, and I get, I'm going to put it on top here, 56.7022. It keeps going on, but I'm going to stop there. Now I'm going to subtract. So minus 56.5783, and I get 0.1239. It says to the nearest hundredth, which is right here. So it's going to be 0.12. Sounds like the engineers did a lot of work to only make it 0.12 meters taller. But that would be your answer, 0.12. And I think that is the last question. It is the end of session 2. So that is it for the practice Florida geometry end of course exam, found on fsaassessments.org. If you want to find part 1, it should also be in this EOC thread. Easy to find. I hope it was helpful.